Today I will present our work, Temporal-Aware Reasoning Optimization for Video Temporal Grounding. Video temporal grounding aims to find the start and end timestamps of a specific event in a video, based on a text query. For example, to localize "the guy plays the saxophone again," the model must accurately identify the timestamps of the two saxophone playing events and reason about their temporal relationship. Recently, post-training multimodal large language models using reinforcement learning have shown great promise in handling these complex queries. Despite recent progress, existing RL-based methods often generate superficial reasoning. As shown in the left figure, instead of focusing on the critical evidence needed for grounding, they tend to produce generic descriptions of the video. Such reasoning contributes little to the final localization result. There are two main reasons. First, RL training relies on random exploration, which blindly searches a huge reasoning space without guidance. Second, most reward functions only evaluate the final prediction accuracy and ignore the quality of the reasoning process itself. This raises an important question: what constitutes effective reasoning for video temporal grounding? Effective reasoning should selectively attend to critical visual cues and anchor them to specific timestamps. To evaluate reasoning quality, we propose a key observation. If the reasoning truly depends on important temporal evidence, then disturbing the relevant frames near the ground truth moment should significantly reduce the model's confidence. This provides a practical way to assess reasoning quality. Based on this insight, we propose temporal-aware reasoning optimization. First, constructive reasoning exploration teaches the model to identify critical visual cues and adopt the thinking with time paradigm. Second, a temporal sensitivity reward assess reasoning quality by the confidence drop after shuffling near GT and explicitly rewards reasoning that depends on temporally relevant evidence. Third, a progressive curriculum gradually transitions the model from guided reasoning to autonomous reasoning generation. Let me first introduce constructive reasoning exploration. The goal is to provide high-quality reasoning initialization during RL training. We first generate dense captions throughout the video. These captions serve as candidate visual cues. Then we randomly sample different combinations of captions as reasoning trajectories, allowing the model to explore diverse evidence patterns. Finally, we keep and learn from reasoning trajectories that achieve high rewards. This process effectively teaches the model which visual cues are useful and the pattern of thinking with time. Next is our temporal sensitivity reward. We first compute the average log probability of reasoning tokens on the original video. Then we randomly shuffle frames around the ground truth region and recompute the confidence. If the reasoning truly relies on temporally relevant evidence, its confidence should decrease substantially after shuffling. Therefore, we use this confidence drop as a reward signal. The final component is the progressive curriculum. A challenge is that constructive reasoning is only available during training. Therefore, we adopt a two-stage strategy. In the first stage, the model learns from constructive reasoning and acquires the ability to identify critical cues and temporal relationships. In the second stage, we gradually remove the external reasoning guidance and allow the model to generate reasoning autonomously. This smooth transition helps bridge the gap between training and inference. We evaluate on 4 public VTG benchmarks. Our method achieves state-of-the-art performance across all 4 benchmarks, and the improvements are consistent across different base models, demonstrating the generality of our framework. We further conduct ablation studies to understand the contribution of each component. Using the temporal reward alone already brings clear improvements. Using constructive reasoning alone actually hurts performance because such reasoning is unavailable during testing. However, when combined with the progressive curriculum, constructive reasoning becomes highly effective and leads to further gains. Finally, here is a qualitative example. Our model generates reasoning that is explicitly grounded in visual details and timestamps. The paper, code, and project page are available by scanning the QR code. Thank you for your attention.